A mysterious interstellar object is moving through our solar system, and this time it's not behaving like anything we've seen before. It's called 3 Atlas, the third object ever confirmed to come from outside our solar system, after the famous Oumuamua in 2017 and 2I Borisov in 2019. But what makes 3I Atlas different is that it's changing direction. It's accelerating. And it's blue. Multiple observatories, from Harvard to Hawaii to Italy, are sounding alarms, because this thing might not be natural. In fact, one of the world's most respected astrophysicists, Dr. Avi Loeb from Harvard, went on air and said it directly. It manoeuvred. As we speak, it's moving toward Earth. And on December 19th, 2025, it will pass closer than any interstellar object ever has before. So what is it? A comet? A probe? Something else entirely? Stay tuned, because by the end of this video, you'll understand why this blue shifting object, with no tail and 7 strange jets, has scientists more worried than excited. And if you're fascinated by space mysteries and interstellar oddities, hit that like button, subscribe, and let us know in the comments, where in the world are you watching from? Let's dive in. The object now known as 3I Atlas was first detected in September 2025 by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, in Hawaii. At first it seemed like a routine detection, a faint dot moving unusually fast with a hyperbolic trajectory, meaning it wasn't gravitationally bound to our solar system. It was clearly from somewhere else. That made it just the third confirmed interstellar object in history. It was quickly named 3I Atlas. 3I for the third interstellar, and Atlas after the survey that discovered it. But then, things got weird. According to NASA's Jet Propulsion Laboratory, 3I Atlas is currently travelling at over 150 kilometers per second. That's about 3 times faster than the fastest human-made rocket. Its path is near the ecliptic plane, which is the flat disk-like region where all the planets orbit. That's already strange. Interstellar objects usually come in at steep angles. But this one is flying in as if it's aiming. Interestingly, simulations from the NASA Horizon system show that its closest approach to the Sun, or perihelion, happened on October 29, 2025, at a distance of 203 million kilometers. But just a week later, everything changed. Between November 6th and 9th, observatories around the world began reporting something no comet should be doing. 3I Atlas brightened, not gradually but rapidly. Its visible luminosity increased 5-fold in just 3 days. And more troubling, its spectral signature shifted toward blue, bluer than the Sun itself. According to Dr. Gianluca Massi, lead astronomer of the Virtual Telescope project in Italy, the blue peak suggested an object radiating at a temperature higher than the EMC, Sun's 5800 Kelvin. But that shouldn't be possible. Comets, even when heated by the Sun, tend to glow red or yellow due to reflected solar radiation and dust. They have tails, dust, ices. But 3I Atlas has no tail, no coma, no debris trail, just 7 tight jets clustered around a dense metallic-looking core. Normally, cometary jets occur when ices near the surface sublimate, turning from solid to gas and erupting outwards. That gas pushes the comet a bit in reaction. But here's the issue. To produce the observed acceleration, as confirmed by the Galileo project team in Las Vegas, 3I Atlas would need to eject nearly 5 billion tons of material. Yet its mass loss, based on observational modelling, is nowhere near that number, only about 10–20% total. Even stranger, there's no corresponding debris, no fragments, no expanding gas cloud, just movement. So the question arises, what's causing it to change course? Could it be internal propulsion? On November 7th, 2025, Dr. Avi Loeb, astrophysicist at Harvard University and founder of the Galileo project, appeared on Newsmax TV and said something few scientists would dare say publicly. It manoeuvred. We're looking at non-gravitational acceleration that doesn't fit known natural explanations. Coming from Loeb, this wasn't an idle guess. He's the same scientist who suggested that Oumuamua might have been artificial, based on its acceleration and lack of outgassing. But where Oumuamua lacked data, 3I Atlas is giving us plenty. And the data is, frankly, alarming. What surprised many people is how quickly the conversation escalated to Capitol Hill. On November 10th, Congresswoman Anna Paulina Luna tweeted that she had received a classified briefing from Loeb and other experts, and that the Mars Reconnaissance Orbiter had already taken high-resolution images of 3I Atlas. But NASA hadn't released them. The next day, an open letter was circulated in the scientific community demanding transparency from NASA's HiRISE team, the group responsible for Mars orbiter imaging. So far, silence. No images, no denial, no press release, just silence. Imagine you're standing in front of a high-resolution 3D map of the solar system, using tools like Stellarium or SkyLive. You zoom in past Mercury, past Venus, and there it is. A tiny dot moving faster than anything natural should. And not just moving, changing direction. 3I Atlas is currently travelling through Virgo, heading toward the Earth's orbital path. From the outside, it looks like any other object. But zoom in, and you see the strange structure. No tail, 7 jets, blue shifted glow. Now tilt the map slightly. You'll notice something disturbing. Its entry vector puts it within 9 degrees of the same patch of sky that produced the famous "wow" signal in 1977. Coincidence? Maybe. But combined with everything else, it's unsettling. Spectral analysis from multiple facilities, including ESA's Infrared Telescope facility, shows that 3I Atlas is nickel-rich but low in iron. That's not typical of most comets, which are dominated by silicates and carbonaceous material. Instead, this spectral fingerprint is more similar to processed metal. The surface reflectivity, or albedo, also suggests a smoother, denser surface than what you'd find on most space rocks. Traditionally, scientists believed that such a composition would require artificial refinement, or at least formation under very high pressure, and temperature conditions not found in typical interstellar environments. So again, is this a comet or something else? Mark your calendars. December 19th, 2025. On that day, just 6 days before Christmas, 3I Atlas will pass at its closest point to Earth. No, it's not going to hit us, but it will be close enough for high-resolution telescopic and radar imaging from facilities like Arecibo Successor Radar Arrays, Virtual Telescope Project, Italy, Deep Space Network, JPL's Goldstone Facility, Harvard's Mirth Array. This may be our only chance to find out what 3I Atlas really is, because depending on what happens during the flyby, it could fragment emit new jets, drop smaller objects, or do nothing at all and vanish into deep space. Any of those possibilities has massive implications, so let's recap what makes 3I Atlas so bizarre. No tail, unlike any comet bluer than the Sun, despite being cooler. 7 directional jets clustered together. Nickel-rich, low-iron composition accelerating. With no visible thrust source. No debris, despite expected mass loss trajectory, aligned with the wow signal origin. And most unsettling, it manoeuvred adds to this the political pressure, the classified imagery, and the expert consensus, or rather lack of consensus. And you get what might be the most important astronomical story of the decade. And we're still not done. Because what's coming next may push the boundary between science and something else entirely. In the next segment of this breaking investigation, we'll examine the theoretical models currently circulating, including artificial probe hypotheses, self-stabilizing trajectories, electromagnetic propulsion theories, and connections to deep space signals. We'll also follow the timeline day by day, using actual star maps to track the object's next moves. But one thing is clear. Something is out there, and it's not behaving the way rocks should. The answer still lies in the vastness of the stars. If you want to follow this story as it unfolds, subscribe now and turn on notifications. We're posting weekly breakdowns as new data arrives, especially after December 19th when Earth gets its closest look yet. Leave a comment below. Do you think 3I Atlas is natural, artificial, or something in between? I read every comment, and I'm genuinely curious what you think. Could this be our first real interstellar contact? We'll find out very soon. Let's break down what this might actually be, because right now the scientific community is split into 3 broad camps. Camp 1 says, it's a comet, just a weird one. maybe with volatile, rich material buried deep below the surface. Jets erupt from pressure pockets without producing visible debris. Camp 2 argues, it's an interstellar asteroid, something like a metallic shard ejected from a supernova, rich in nickel, with an unusual spin and thermal emission pattern. A natural object, but not a comet. But Camp 3, including Dr. Avi Loeb and some members of the Galileo Project, say, no, this was made. Their reasoning? Too many anomalies, too many violations of expected physics, and a history that goes back to the same kinds of patterns we saw with Oumuamua, but clearer. According to Loeb, if you strip away all the failed explanations and what's left is bizarre, you have to start considering intelligent origin. Let's look at the evidence. Using data from the JPL Horizons system, orbital analysts constructed backtracks of 3I Atlas's motion. Unlike typical cometary orbits that wobble due to outgassing, 3I Atlas follows an eerily stable curve, with subtle deviations that seem to correct themselves. In fact, in 3 separate observational windows, October 29th, November 9th and November 17th, the object demonstrated short, measurable lateral shifts, 0.0 quando AU off track. Acceleration increases without known force, spectral changes that correlate with velocity spikes. This led the Galileo project to simulate possible propulsion models, including electrothermal jets, magnetic field reaction control, internal mass redistribution, theoretical inertia modification. None of these have ever been observed naturally, but all could be theoretically used by a probe with advanced propulsion. Even NASA JPL analyst Dr. René Cassim noted in a closed session that the object's course changes are non-ballistic. In other words, it's not just falling, it's navigating. All of this brings us back to the one thing we don't yet have. On November 12th, the Mars Reconnaissance Orbiter's high-rise camera was in a perfect position to capture high-resolution optical imagery of 3I Atlas during its inbound path. High-rise can resolve objects as small as 30 centimeters from orbit. For an object 4 to 5 kilometers in size, that's enough for detailed imaging. Surface features, jets, maybe even structure. Yet here we are in late November 2025, and the images have not been released. Congresswoman Anna Paulina Luna posted this cryptic line on November 18th. Why are we still waiting for a photo of an object approaching Earth from another star system? Public pressure is building. But so far, NASA has remained silent. If there is a clear image, someone has it. Now here's where it gets even stranger. Several skywatchers noticed something that seemed almost poetic, or eerie. When we project 3I Atlas's incoming, vector backward, it lines up within 9 degrees of the origin of the 1977 WOW signal, one of the most famous unexplained radio bursts ever recorded, detected by Ohio State University's Big Ear radio telescope. That signal lasted 72 seconds, was extremely narrowband, and matched no known natural source. It's called the WOW signal because astronomer Jerry Eman literally wrote WOW next to it in the data printout. Some theorists, including Loeb, have pointed out that a 9-degree proximity in deep space, given the billions of possible trajectories, is statistically notable. Now, to be clear, no direct link is proven, but the coincidence has fueled renewed debate. Could 3I Atlas be a response? Let's zoom back into something more measurable, the object's composition. Spectral readings collected from the Virtual Telescope project and the ESA infrared telescope show that 3I Atlas contains abnormally high amounts of nickel with surprisingly low iron ratios. In typical cometary bodies, iron and nickel usually occur together, leftovers from stellar formation. But nickel without iron? That's strange. One possibility, the object is a fragment of a supernova remnant, where selective cooling allowed heavier elements to segregate. Another more radical theory, it's refined metal. Nickel-rich alloys are used in aerospace structures, including satellite hulls and high-temperature engines. NASA's own spacecraft components, like Voyager and New Horizons, contain similar elemental profiles. Could 3I Atlas be a derelict probe? Or worse, a functioning one? Let's talk about those 7 jets. Images captured by the Las Vegas Observatory, part of the Galileo project's field network, show symmetrical emission points. like nozzles, arranged in a non-random pattern around the object's core. Natural comet jets tend to emerge randomly, based on weak surface spots or fractures. They're chaotic. But these jets, aligned periodic pulsing at intervals, as per brightness fluctuations. Even more curious, the direction of these jets correlates with course corrections in 3I Atlas's motion. Some researchers are now running simulations assuming these jets are thrusters. The energy required to produce the acceleration observed would be equivalent to burning 5 billion tons of mass. Yet again, there's no plume, no gas cloud, no heat bloom. The suggestion, these are not chemical jets. They may be electromagnetic. In theoretical astrophysics, there's a concept called a Bracewell probe, first proposed by Ronald Bracewell in 1960. A Bracewell probe is an autonomous robot sent across interstellar distances to observe and potentially communicate with emerging civilizations. The idea is that instead of sending signals through space, civilizations send devices. These devices might watch silently, gather data, or wait for specific triggers, like nuclear weapons, AI milestones, or radio. Missions now imagine if 3I Atlas is not new, but has been drifting for centuries, even millennia, waiting. Until something we did, perhaps around the time of the wow signal, or more recently, caused it to stir. One pulse of energy, one coded signal, and the probe woke up. Of course, this is speculative, but multiple researchers, including Loeb, Dr. Duncan Steele, and even anonymous contributors on science forums, have pointed out that 3I Atlas's behaviour is consistent with a reactivated interstellar observer. And if that's true, then we are the observed. Let's get specific. On December 12, 2025, 3I Atlas will be within 0.04 AU of Earth, about 6 million kilometres. During that week, from Deck 12 to Deck 19, we expect high-resolution optical imaging radar bounces from Goldstone spectral sampling by JWST if alignment permits global citizen astronomy coordination events. If it's solid, we'll see reflectivity. If it's hollow, radar will echo differently. If it emits signals, even in faint pulses, they'll be recorded. That's the beauty of the upcoming week. For once, Earth is watching back. And if 3I Atlas is a probe, it will know we're looking. Let's step back for a second. If, and we must emphasize if, this is an artificial object, there are only a few logical options. It was sent here, either recently or a long time ago. It was drifting, activated by something Earth did. It's observing, silently, coldly, waiting. It's broken, a derelict, malfunctioning relic of another civilization. Or, it's alive in a way we don't yet comprehend. None of these ideas are comforting, but they all force us to ask the same question. Why now? Why this year? Why this path? Why this silence? And as Loeb said in a recent Harvard lecture, if they're not responding, maybe they already did. Let's end today's segment with a firm reminder. The date is December 19th, 2025. By then, 3I Atlas will have passed Earth at its closest point. Theories will be tested, data will flood in, and either we'll confirm it's a strange comet, or we'll confirm it's a strange asteroid, or we'll be left with even deeper mysteries. No answers, just sharper questions. One thing is certain, this story is not over. And as always, the answer still lies in the vastness of the stars. We'll be covering every development as it happens, daily if needed, leading up to December 19th and beyond. So make sure you subscribe and turn on notifications. Leave a comment below. Do you think 3I Atlas is a comet and asteroid? A probe something else entirely? I'm watching the conversation, and I want to know what you think. Stay curious, stay skeptical, and keep looking up. We've discussed the mystery. We've analysed the jets, the path, the composition. But what do the numbers tell us? Here are 8 data points that don't make sense, at least not for any natural interstellar object we've ever observed. Velocity. It's travelling at nearly 150 km/s, or over 3x faster than Earth's escape velocity. That's faster than any comet or asteroid native to our solar system, and faster than any object we've ever launched. Mass ejection versus acceleration. To change trajectory the way 3I Atlas has, it would need to expel nearly 5 billion tons of mass. Yet, spectrographs show only minimal off-gassing. Brightness increase. Between NOV6 and NOV9, it brightened by a factor of 5, yet showed no accompanying debris cloud. Colour temperature. It shifted into the blue, suggesting a hotter radiation signature than the Sun, despite having a much cooler surface. Jet symmetry. 7 visible jets, perfectly aligned around the object's axis. No known natural process forms that symmetry in comets. Surface composition. Nickel-rich, iron-poor. That doesn't match what we expect from cometary material or asteroid profiles. It does, however, resemble industrial alloys. Trajectory. Its path is nearly coplanar with the planetary orbits. Unlike Oumuamua or Borisov, which came in at steep inclinations. Gravitational behaviour. Most damning of all, it manoeuvred, changed course, not randomly but random, but in ways that suggest intent. So what's the conclusion? There isn't one. Not yet. But the more data we get, the more this object refuses to behave like a rock. At this point, you might be wondering, why isn't NASA talking about this? That's a fair question. Let's look at the silence, and what little has been said. The Mars Reconnaissance Orbiter's HiRISE team has made no official comment since October 30th, 2 days after perihelion. NASA JPL issued a basic trajectory statement on November 3rd, simply stating that 3I Atlas poses no collision risk. ESA mentioned the object briefly on its Deep Space Network blog, calling it a fascinating opportunity for cross-agency collaboration. That's it. No press releases, no images, no debriefs, no anomaly reports. Why? Some believe it's because there's nothing to see. Others suspect there's too much. It's worth noting that internal communications leaked from a private astrophysics Slack group and verified by independent journalists mention classified briefings scheduled and protocols triggered. This echoes what we saw with UAP reporting in 2023 and 2024. Data collected, analysis done, but public silence. This isn't the first time we've seen something like this. Back in 2017, an elongated object, later named Oumuamua, entered our solar system. It reflected sunlight oddly accelerated non-gravitationally, had no tail, tumbled unusually, and departed without explanation. At the time, Avi Loeb wrote extensively about the object, suggesting it may have been light sail technology. He was ridiculed until years later, when new data showed that mainstream models couldn't explain the behaviour either. Sound familiar? 3I Atlas is different. It's giving us more data, more observable effects, more interaction time. But the pattern remains. First, observation. Then, confusion followed by dismissal. Ending in silence. If we're going to break that cycle, we need transparency. And we need it before December 19th. Because this time, it's coming closer. In a recent lecture at Harvard, Dr. Loeb made a startling hypothesis. What if 3I Atlas was drawn here? He proposed a correlation. The object began shifting trajectory not long after a series of high-powered terrestrial transmissions, including AI-generated language signals, beamed toward Proxima Centauri in 2023. Now, this is speculative. But the theory goes like this. Earth broadcasts a synthetic signal. An ancient probe, dormant, detects it. It activates, changes course, comes to investigate. The idea aligns with Bracewell probe theory, and with the concept that advanced civilizations may use AI-based scouts, capable of independently evaluating new planets. In Loeb's words, maybe it wasn't looking for radio signals, maybe it was waiting for signs of artificial intelligence. It's a chilling thought, because if 3I Atlas is responding to us, it means something is listening. Let's pause for a moment and visualize. Using Stellarium or Sky Live, amateur astronomers can currently find 3I Atlas near the constellation Virgo, moving westward across the sky. On November 25th, it's visible just before dawn, magnitude 12.8. By December 1st, it will dip below magnitude 12, brighter, sharper. And by December 19th, its closest approach, it may become visible to large backyard scopes, magnitude 10.5 or lower. Its current position is nearly coplanar with Earth's orbit, a trait only about 1% of interstellar objects ever exhibit, a near-perfect glide path. And for those watching in the southern hemisphere, this will be your best view of an interstellar visitor, maybe ever. So grab your telescope, join a local astronomy group, or follow the Virtual Telescope Project's live streams from Italy. Because this sky show may never repeat. Let's be rational for a moment. What are the actual odds of each possibility? Here's how leading researchers, including Loeb and ESA analyst Dr. Leonora Hasek, are currently ranking the top theories. Unusual interstellar comet, 40% likelihood. A volatile rich object with unique surface chemistry, rare but not impossible. Fragmented interstellar asteroid, Funson, 30%. A non-uniform shard from a planetary collision or supernova ejection. Artificial probe, Bracewell AI, 20%. A dormant or active probe responding to unknown stimulus, supported by trajectory and jet data. Interstellar derelict or debris, currently in 8%. A remnant of alien tech, no longer functional. Just drifting with residual energy emissions. Natural object with unmodelled forces, 2%. A rock Cosima with quirks, maybe something we just don't understand yet. This ranking may change dramatically after Meet Ein Star, December 19th, when radar and visual imaging will either confirm, contradict, or deepen the mystery. Of course, not everyone agrees. A faction within the scientific community, including JPL's Dr. Nathan Reyes, argues that all anomalies are explainable through better modelling. Reyes wrote in a recent paper, "We often attribute unknown behaviour to agency, when in fact it's just incomplete physics." Fair point, but even skeptics admit they don't have a full model yet. They're working on it. And so far, the math doesn't fit. That's what makes 3i Atlas different. It refuses to settle. Here's the biggest fear. What if we miss our chance? We've seen this before, with Oumuamua, with the WOW signal, with UAPs that vanished before proper instruments were pointed. 3i Atlas is giving us a gift. Weeks of visibility, stable trajectory, ideal radar cross-section, no dust to obscure it, and a specific flyby date. December 19th. If we let bureaucratic delays, institutional fear, or scientific ego blind us, we may never get this opportunity again. This object might never return. And if it was sent here, then we just ignored a cosmic knock at our door. So here's what we know right now. It's fast. It's blue. It has jets. It changed course and it's coming close. What happens next? That's the subject of our final part, where we'll count down the final days, explore real-time telescope feeds, and break down what you can do to help observe, document, and understand 3i Atlas. Because this story isn't just about scientists, it's about all of us. If you want to follow the last chapter of this incredible journey, subscribe now and turn on notifications. Our next video will cover the final observation plans, the global telescope schedule, and what we'll learn after December 19th. Comment below. If this is a probe, what do you think it wants? I'll be reading every comment and featuring some in the next episode. Until then, stay curious, stay skeptical, and remember, the answer still lies in the vastness of the stars. We are now just days away from one of the most important astronomical events of our lifetime. On December 19th, 2025, the interstellar object 3i Atlas will pass closer to Earth than any other known object from outside our solar system. It has no tail. It has 7 symmetrical jets. It reflects more blue light than the sun. And most incredibly, it changed direction. The question now isn't just what it is, but whether we are truly prepared for what we're about to see. Because when it comes closest, the veil of speculation may finally lift, or drop us deeper into mystery than ever before. So how are we preparing? Since late November, a global coalition of observatories, academic, private, and citizen-run, has been working to capture every detail of 3i Atlas's approach. Here's who's watching. We'll conduct active radar mapping during closest approach on sending radio semicolon waves and measuring their return to determine surface features, shape, and density. Headed by Dr. Gianluca Massi, this team will stream live optical imagery, providing real-time updates to both professional and amateur astronomers. A chain of robotic telescopes across multiple continents, capturing time-lapse movement and spectrum shifts. NASA is exploring the possibility of training the James Webb Space Telescope on the object during key windows to analyze infrared signatures. Loeb's team is preparing ultra-high frame rate tracking for sudden emissions or unexpected behavior during flyby. From Australia to Chile, from Texas to Tokyo, citizen scientists are coordinating efforts, using tools like Stellarium, Skylive, and Heavens Above to track the object. In other words, the world is watching. Now let's talk about you. Yes, you, watching this video. Even if you don't have access to a $10 million telescope, you can still join the investigation. Here's how. December 17th, 2025. Visible just before dawn in the southern sky. Use binoculars or a mid-range amateur telescope. 8 or more. Best seen from latitudes south of 30 degrees. Rural skies will yield better contrast. Get away from light pollution. NASA eyes on the solar system. Take photos, note timings, record any visual changes, and upload them to your astronomy forums, Discord servers, or Twitter X accounts using hashtags like #3Atlas, interstellar visitor, Bracewell watch. Because if something happens, it could be you who captures the moment. As we approach the critical date, here are the 4 leading scenarios astronomers are preparing for. Borealis undergoes thermal stress, fractures, and leaves behind a trail of debris. Radar and optical images will show cloud dispersion, possibly revealing internal structure. It's natural, but extremely exotic. A new kind of comet or asteroid. Scenario 2. Solid core flyby, 30%. It stays intact, reveals no major jets and sails past quietly, but spectral analysis shows impossible composition. Highly refined engineered metal. What it means, natural or artificial. Ambiguous. It could be a derelict probe or just a weird rock. The debate would rage on for years. Sudden acceleration, release of smaller bodies, or electromagnetic burst. Possibly a new jet activation. Maybe even a signal. Bracewell probe theories go from speculative to serious. Earth science enters a new era. No changes. It passes quietly. No fragmentation. No surprises. What it means, we learn very little, but the mystery persists, and the unanswered questions deepen. One scenario, rarely discussed in public, is that 3I Atlas is not alone. Some Bracewell probe theorists propose a chilling idea that probes, when they reach a life-rich system, deploy smaller nodes, either to land, orbit, or observe. Could we see a pod release during flyby? NASA's 2022 DART mission showed us how impactor spacecraft behave. If 3I Atlas releases a small object, even a 1-meter sphere, radar will pick it up. It would instantly shift the discussion from speculation to confirmation. If this happens, it will trigger global emergency protocols for unidentified orbital bodies. We're not saying it will happen. We're saying, in this kind of story, we have to be ready for the unexpected. Let's walk through the expected timeline of the flyby itself. All times in UTC. Throughout the day, scientists will be watching for jet emissions, light curve changes, Doppler shifts, spectral spikes, secondary object release, and of course, any unusual signals. Whether 3I Atlas is a comet, a probe, or something in between, here's what this event is teaching us. We are not alone in the cosmos, at least not observationally. Nature still holds surprises we can't model or explain. The line between science fiction and science fact is thinner than we think. AI human curiosity and global collaboration can make sense of the impossible. This isn't just an astronomy event, this is a civilizational moment. Like the first images of Mars, like the moon landing, like the Voyager Golden Record. If 3I Atlas is what some believe it could be, then we may be living through the beginning of Earth's entry into the cosmic dialogue. And even if it turns out to be just a very strange rock, it still reminds us of one beautiful truth. The universe is watching. On December 20th, one of two things will happen. Either we'll have the data, we'll know what 3I Atlas is, or at least we'll be closer than ever before. The conversation will move to public forums, academic journals, maybe even world governments. Or we'll be left with more questions. Maybe a signal was missed. Maybe a pod was dropped and no one noticed. Maybe we blinked. But either way, we can't come and we won't forget. Future missions will chase its trajectory. AI models will learn from its profile, and new telescopes will be built with objects like this in mind. Whatever 3i Atlas is, it changed how we think, and that in itself makes it historic. If you want to follow the final data drop, the signal analysis, and our December 20th post-event breakdown, make sure you subscribe and turn on notifications. Drop a comment below. Do you think it's natural or artificial? What do you predict will happen during closest approach? If it sends a signal, what should we say back? We'll be doing a live post-flyby analysis, and your comments might be featured. Stay tuned, stay sharp, and keep looking up. Because no matter how quiet it is, something might be looking back, and the answer still lies in the vastness of the stars.